structure block, why we have to categorize into text, code, image, file, and reference, and how to chunk intelligently. So, in this video, we are going to cover how we can embed these chunks and how we can store in vector database and how we can retrieve and how we can build complete RAG pipeline. Okay. So for this embedding model, I am using as Allmin ML6V2 from sentence transformer. So due to this, I am loading the models via sentence transformer and I am checking what is the dimension of this sentence transformer. As you can see, the dimension of this embedding model is 384. What it means whatever the context you give, you cannot give more than the maximum input length, as I mentioned how to decide chunk size and all, right? In that you will get to know. So if you give the sentences or the tokens or the characters and it is less than the maximum input size for this particular embedding model, so what it will do, it will create the vector which the size is 384. Whatever the context, even if you give 5 line or 10 line or like complete input maximum characters, always it will create the 384 dimension of the vector. Okay. Now once you loaded that, then what we are doing, we are just passing text and then we have to convert into numpy. We are setting it as a true and normalize the uh, embeddings for mainly cosine vectors. So embedding type as float32, we will get to know why we are giving it. So once you provide the text, what it will do, it particular this model will provide you the embeddings. So uh, chunks, as you know, we are using chunks in the LangChain document. So what we are doing, we are taking, it will have a page content and metadata. So it will take a page content as a in a loop and it will provide that text to embedded documents and embedded documents provide you the embeddings. Now you got the embeddings. As we see why we chose vector data as a Milvus. So we are installing Milvus Lite. So now how to store this embedding inside the vector database. First for that we need to know the three main steps. First step is the connect collection type and we are storing these embeddings in local databases. So we have to create Milvus knowledge.db which will create the database in a local machine. So then collection name I am giving pain medicine guide base. Okay. So first step is whether this particular knowledge collection name is present or not. If it is present, then what I will do, I will delete that and recreate it. Okay. The second step, first one is a collection name, which collection in a database you are storing. Second one is schema. Schema is very important. What do you want to store inside that particular collections? So as you see here, ID, vector, text, and source. ID, what I am doing, I am just taking this. What do you say, auto id, whatever the Milvus will create, no, that I am setting it true, so it will create its particular id, or you can use uuid and you can create the id, unique id for that, and you can store also. And then if you see vector is float vector and the dimension is same as a dimension should be same as our embedding model. Then we are storing text as it is, and if it is there is a source, we are adding the source from the metadata. Text is for the content, original content, vector is for the embeddings, and source is for the metadatas, and ID we are creating this schema. And after that, what we are doing, we are creating the third most important step is indexing. Which indexing parameters are you are using? Here, if you see here, what I am doing, add a index for the vector particular embeddings. I am choosing indexing type as flat and matrix type as IP. And if you see here, Plat if you consider, right, exact nearest neighbor search it will do, and most accurate, but it is slower. And matrix type I am giving inner product, okay. But these things you can change. Example L2 cosine alternative matrix also there. These are this plat is works for very good and less size. But if you want to work for like very large data set, then you have to use HNSW. So what it will do, it will, if you see this map here, right, for accuracy, it will be a very exact for less data, and it will be approximately that 95 to 99% for HNSW. Speed will be slower, and here it is very fast, and scalability is poor. For as I mentioned, it is for constructed for many like large data sets. Yeah, you can configure the search and then check the output. First start with the plat, then start with the HNSW, see the timings, see the quality of the retrieved documents, and based on that you can decide which is required for you. So that I will cover in the later sessions. How you can evaluate and which parameter works best for you, you can do at the end of the session. Okay. Now, as I mentioned, one is collection name, second one is schema, and third one is the indexing type. Okay, those all things you can provide and create the collections. Okay, so once you created a collection, what you have to do, prepare Milvus record. What prepare Milvus record is, example we are using LangChain documents, right? But Milvus need its own type of a dictionary, so we have to convert them. Example vector always, yeah, the dictionary fields of the record, like Milvus is vector, text, and source, and other metadata as it is. Okay. So what you can do, example, embedding to the list because it always accept a list. We are converting this embedding into a list and sending it. And the text means our where we are stored in LangChain chunk dot page content. It will be stored in text. And source is a metadata. So what we are doing, metadata get source or any other metadatas except the source and ID as we are adding it. So it will be adding on here. That is what prepare Milvus records. Then you have to insert this to a Milvus. So when you are doing Milvus insert to this, we are using the batch processing and batch size is 64. Based on that, it will insert. Okay. Now, so what we have to do after that, we have to flush it and load to the connection. So as you can see here, flush is persist data to disk. Load collection means load into the memory for querying. Okay. Without flush, what happens? Data may stay in the memory buffer but not durable. But without the load collections, right? You cannot search efficiently. That's why we have to flush and load it. And then once you loaded it, then all the data already stored in your vector database means data ingestion process is done. Okay. Till now we have done till data ingestion process. We took from PDF pages, then loaded the PDF pages, then we took the page content, metadata, chunk, decided chunk size, overlap, and even text encoder, based on text encoder, then structured blocks, then understand the layout of PDFs and tables and code, how to handle all these things, structured blocks, then created a chunking. The main part is chunking. After chunking, you just need to load the embedding model and you have to write a schema for vector database and then you have to flush and load to the collections. Now we will talk about retrieval. Till now, what we did only data ingestion process. After this, we are going to talk about retrieval process and augmentation and totally as a RAG.